Hi there, in this video we're going to look at single period inventory models. And there are two submodels. The first one is continuous demand and the second one is discrete demand. The difference between these two is that if you have probability distribution that is specific to problem context, your problem context, then you're going to use discrete demand because it's going to be more accurate, okay? If you don't have probability distribution, you don't have the data that's specific to your problem, then you can use continuous demand models. Because in continuous demand model, you're going to refer to the standard C table or the standard normal distribution curve. And these are the steps. So the first step is to find out the two costs, and then you're gonna plug those in, right, to the two costs here, plug those in right here to get service level or probabilities. So this is gonna be the probabilities under the standard normal curve from the left, from negative infinity to the right. Okay, so be this area here. So let's say if your service level or probabilities is 0.80 or 80%. Okay, so it's going to be the area, this area here. And in step 3, you're going to look for z values. Okay, so z values is the standard deviation in the standard normal curve. You can use the table in the back of the textbook, or use this function in Microsoft Excel. Alright, and after you have the z value, you're going to plug it in. So we're going to use this formula to determine the optimal order quantity. So this is what we're interested in. We want to know what is the optimal order size given the mean that we have and standard deviations. Okay, all right, so this is mean and standard deviation is from your data. Okay, it's from your sample, and z right here is the standard deviation in the normal distribution curve that corresponds to the two costs right here. All right, let's look at the example. Here, the cost, to determine the two costs here, we need to know the cost and the price and the salvage value. Okay, so the cost is, this is the cost, so cost per unit is 20 cents, price is 50, right? So profit margin per unit, it's 30 cents. So the cost per unit of demand underestimated or lost sales or opportunity cost is 30 cents. Okay. Next, cost per unit of demand overestimated is 20 cents. So this is the cost, salvage value is 0. So if you purchase 12 copies in the morning and you can sell only 10, you have 2 left, you couldn't sell it, it's gonna cost you 2 times 20 cents. Right, it's going to cost you 40 cents because you couldn't sell the unsold copies back. But if you can sell the unsold copy back for 10 cents, let's say 10 cents, okay, 10 cents, you're going to plug in 10 cents right here instead of 0. Alright, so this is how you determine the two costs. After you have the two costs, you're going to plug them in to determine service level or the probabilities that order quantity or stocking level can satisfy the demand. So let's take a look here. The service level is 0.6 or 60%. Okay. So the probability is 0.6 or the chance that we can satisfy the demand is about 60%. Alright, so 60% of 0.6 is the area under the curve here. So we're going to look for Z or standard deviation in the normal distribution curve. Okay, and you can use Excel function. Okay, 0.6 is the only argument that is required. Okay, and then try it. Use Excel and try it yourself. Okay, and then you're going to get Z equal to 0.253. So that is the standard deviation in the normal distribution curve. You're going to plug it in right here, right, for Z. And okay, this two is given. Okay, this is the mean and standard deviations from here. Mean, standard deviations is 1. And here is our answer. The optimal order size is about 93. So with the information that we have, the order size of 93, it's considered optimal. So if you want to maximize the profit, you're going to purchase 93 copies in the morning. All right, and this is how you use the continuous demand model. You don't need probability distribution that's specific to your problem context. No, you can use the standard normal distribution instead, so it's much easier, right? We don't need a whole lot of data. All right, I'm going to stop here and make sure you look at this slides, the application of the single period model. Okay. All right, in the next video we're going to look at the discrete demand model. Thank you guys for watching. Bye.